A thermostat reacts. It senses temperature, compares it to a target, and flips a switch. An AI agent does something fundamentally different. It decides what to do next, takes action, observes the result, and then decides again. That loop changes everything. An AI agent is a system where a large language model, the same kind of technology behind ChatGPT, doesn't just answer a question. It plans a series of steps, executes them using tools, and adjusts based on what happens. Think of it like the difference between asking a librarian a question and hiring a research assistant. The librarian answers what you asked. The research assistant figures out what questions to ask, goes and finds the information, hits a dead end, tries another approach, and comes back with something useful. That second thing is an agent. Most people think AI is a smarter search box. You type something in, it returns an answer. But a huge category of real work isn't question and answer shaped. It's task shaped. Analyze this data set and send me a summary. Find the bug in this repository and open a pull request. Monitor this API and alert me if anything looks anomalous. A plain language model can't do those things. It doesn't persist between steps, it can't run code, it can't check the result of an action and respond to it. The moment you need AI to do something that takes more than one step, and most useful things do, you need an agent architecture. That's where teams either get this right and build something that actually works, or get it wrong and end up with a loop that spins forever and calls the wrong API 12 times. At the center of every AI agent is what's called the ReACT loop, short for reasoning and acting. It's a pattern, not a framework. The model receives a goal. It reasons about what to do first. It acts by calling a tool. It observes the output of that tool. Then it reasons again about what to do next. Repeat until the goal is complete. Here's what that actually looks like under the hood. The agent gets a prompt that includes the original task, a list of available tools, which are just functions the model is allowed to call, and a running log of everything it has done so far. That log is called the scratchpad. The model reads all of it, outputs either a tool call or a final answer, and the system routes accordingly. If it outputs a tool call, the host application executes that tool. It might be a Python function, a web search API, a database query, a code interpreter, and appends the result back into the scratchpad. Then the whole thing goes back to the model. The model reads the updated context and decides what happens next. This is why context window size matters so much in agent systems. Every round trip adds more text to that scratchpad. Long tasks can exhaust the context window before they finish. And if this is the kind of architecture you want to understand deeply, Stack Future covers one concept like this every week. When the context fills up, the agent either loses earlier steps or needs a memory system to compress and retrieve them selectively. Memory in agents is typically split into three types: in-context memory, the scratchpad itself; external memory like a vector database where past observations are stored and retrieved by similarity; and procedural memory, which is baked into the model weights through fine-tuning. Most production agent systems use all three in some combination. Say you're building a coding agent using LangChain and GPT-4. You give it the task. Find all functions in this repo that don't have unit tests and create a test file for each one. The agent starts by calling a file system tool, something like list files with a path argument pointing at your repo. It gets back a directory tree, then it calls read file on each Python file, parses what it finds, cross-references against the test directory, identifies the gaps. Then it calls write file to generate test stubs. Halfway through, it calls read file on a path that doesn't exist, maybe a broken symlink. The tool returns a file, not found error. The agent reads that error in its scratchpad, reasons that it should skip that file and log the issue, and continues. You didn't write that error handling explicitly. The model inferred it from context. That's the thing that surprises most engineers the first time they build one. The recovery behavior emerges from the reasoning loop, not from code you wrote. An AI agent is a reasoning loop, a model that plans, acts, observes, and plans again, using tools to interact with the world beyond its context window. The architecture is the loop, the scratchpad, the tools, and the memory system. Understanding those four pieces tells you exactly why an agent succeeds or breaks down. If this clicked for you, hit the like button. It genuinely helps other people find the video.